6.1 on number 32, we are asked to solve this system of equations, but since it's 6.1, we can't use our calculator, so we will be using Gaussian elimination. So the first step is to put this in an augmented matrix, which I've done right here. So this is just the augmented matrix taken from that system of equations with x, y, z, and then going down. That's pretty self-explanatory. Now, as it says here, the first step is to get this element to be a 1. And you can do that by multiplying row 1 by negative 1/2. And here's that. So then, this is that matrix. So the first row becomes 1, negative 1/2, 3/2, and 0, and the rest of the matrix stays the same. Now you're done with the first row. The next step is to get this element to become a 0. And if you direct your attention over here, you can do that by multiplying row 1 by negative 3 and then adding that to row 2. And it's important to write down what row 1 is going to be just so you can keep track of that. So row 1 is going to be negative 3, 3/2, and negative 9/2. So when you add that to row 2, you're going to get, the first row is going to stay the same, but the second row is going to become 0, negative 5/2, 11/2, and negative 7. And the third row stays the same. Next step is to get this element to become a 1. And you can do that by doing row 2 times negative 2/5. So what you get after that, the first row is going to stay the same. The second row is going to become 0, 1, negative 11/5, then 14/5. And the third row stays the same. So the next step, you're done with the second row. So the next step is to get this element to become a 0 as well. And you can do that by doing row 1 times negative 5 plus row 3. And again, we have to write down what row 1 is. So row 1 is going to become negative 5, 5/2, negative 15/2, and 0. So when you add that to row 3, this is your matrix. The first row stays the same, the second row stays the same, but now the third row becomes 0, 9/2, 1/2, and 23. So the next step is to get this to be a 0 as well. You can do that by doing row 2 times negative 9/2 plus row 3. And as always, we're going to write down what row 2 is going to be. So row 2 is going to equal 0, negative 9/2, 99/10, and negative 63/5. So when you add that to row 3, you're going to get 1, negative 2, 3/2, 0, first row. Second row is going to stay the same. And third row is going to be 0, 0, 52, 52/5, 52/5. Last step of the Gaussian elimination is you take row 3 times 5 over 52 so that this becomes a 1. And the matrix you get after that is, let me write it down, is 1, negative 1/2, 3/2, 0, 0, 1, negative 11/5, 14/5, then 0, 0, 1, 1. And that is your final matrix. So from this, you don't even have to go into this is in REF form. So you don't have to go into RREF. All you have to do is go substitution from here. So from this row, row 3, you know that Z equals 1. Now, if you plug it into this row, row 2, you can solve for y. So y equals, y minus 11/5 equals 14/5. And if you add that over, y equals 5. Now, you can plug that into the first row right here so that you can get, x minus 1/2 of 5 plus 3/2 equals 0, and that ultimately means that x equals 1. So we have solved this system of equations by using Gaussian elimination. So our final answer is x equals 1, y equals 5, and z equals 1.